Welcome to Astrophiz with Brendan O'Brien. Produced on Yorta Yorta, Pangarang and Kaurna country, we celebrate the first astronomers of this land. Monthly, we explore the universe with the world's leading scientists. For transcripts and more, visit astrophiz.com. And here is Dr. Ian Musgrave with your May SkyGuide. Hello, Ian.
Hello, Brendan. How's things?
Very good, thanks, Ian. And can you tell us what's up in the sky for the month of May?
Well, quite a lot of things are going to be up in the sky for the month of May. The planetary action is still mostly happening in the morning skies, although the evening skies are not too shabby. We've got Venus and Jupiter dominating the northwestern skies in the evening, and Venus is beginning to chase Jupiter, and they should be very close by the end of the month. We lose Mercury in the morning sky, but Saturn and Mars are becoming more prominent. We also have the Eta Aquariid meteor shower, but unfortunately the moon's not going to make it very exciting this month. And with any luck, the Comet C/2025 R3 PANSTARRS may very well be putting on a nice binocular display for us.
Excellent.
So I'll go into my moon statement. So May the 2nd is full moon. May the 10th is last quarter moon. This is good for stargaze in the evening. May 17th is the new moon, which is ideal for stargazing at all parts of the night. And on May 23, the first quarter moon comes back again. But the moon Penelope has not finished. May the 31st is a full moon again. This is our blue moon. We've got a second full moon in the month. So this is also has a very difficult occultation of Antares at the same time. The moon is at apogee when it's furthest from the Earth on May the 5th, and at perigee when it's closest to the Earth on May the 17th. This coincides with the new moon, but of course the new moon being completely unilluminated, seeing a perigee new moon is not on the card. So with the moons out of the way, let's have a look at what's happening in the evening sky. Now, if you're looking at the evening twilight, you've been seeing Venus climbing higher and higher in the twilight. And this continues on in May. But as I've said, Venus is becoming closer and closer to Jupiter. You may have noticed as the twilight deepens and Venus sinks towards the horizon, you can see Jupiter quite clearly not far from Venus. And as the month goes on, they get closer and closer until by the end of the month, Venus and Jupiter are about 2 hand spans apart and looking very nice in the twilight.
Nice.
On the 2nd, Venus is around a hand span from Aldebaran, low in the nautical twilight. And that's the brightest star in the constellation of Taurus. You will need a fair level horizon to see both of them, but it will look quite nice. On the 19th, Venus is close to the 3-day-old thin waxing crescent moon, a few degrees below. And the next day, they're widely separated, but it'll still look very nice. On the 14th, Venus is between the stars Beta and Zeta Tauri, the horns of the bull. But again, this is going to be low in nautical twilight and maybe a bit difficult to see unless you've got a very clear horizon. And as I've said, by the end of the month, Venus and Jupiter are 10 degrees apart. And now Jupiter is still bright and visible for most of the evening, setting around about 10 p.m. In the early evening northwestern sky, Jupiter's forming a broad triangle with the bright stars Betelgeuse and Procyon, and a narrow triangle with the stars Castor and Pollux, as it did last month. It also, at the beginning of the month, it also forms a line with Pollux, Gamma Geminorum, and Betelgeuse. Jupiter's close to the star Delta Geminorum at the beginning of the month, and they're very close, about half a finger width away. But then Jupiter moves back towards Pollux during the rest of the month, leaving Delta Geminorum behind. On the 20th, Jupiter will be up 5 degrees. That's just about a hand span from the waxing crescent moon, looking quite nice. Now, let's go to the morning sky. If you've been able to get up early in the morning, And unlike B, your skies have been clear of cloud. You'll be seeing Mercury lowering in the morning twilight, becoming harder and harder to see, and it'll be lost by the end of the week. It then returns to the western morning sky next month. Mars is low above the eastern horizon in the morning. It's below Saturn. And on the morning of the 15th, Mars will be 5 degrees from the crescent moon. At this time, it forms a broad triangle with Saturn. Saturn also is climbing higher in the morning twilight. On May the 14th, the waxing crescent will be 5 degrees from Saturn, forming a triangle with Mars at nautical twilight. And as you may have guessed from what I said about Mars, on the next day, you've got another triangle formed by the Moon, Mars, and Saturn. So those are the planets, plenty to watch in the morning. So those particular times are the highlights. But of course, every clear night you go out and see the bright planets, they'll be very nice to look at.
Yep.
But let's have a look at the comets. Now, Comet C/2026 A1 mass, which we had very high hopes, broke up and is now a cloud of debris dissipating. Will not be very exciting at all. But C/2025 R3 PANSTARRS, unlike mass, is not a sun-grazer. It gets closest to the sun between the orbits of Mercury and Venus, so it's not in much danger of disintegrating. But at the moment, it's passing through the fields of view of the space telescopes SOHO, Core 1, and STEREO. And perihelion for the comet was on the 20th of May, and it survived perihelion. And we've been watching it transverse the SOHO, Core, and STEREO fields of view, and it's looking very nice. Unfortunately, it didn't get as bright as we thought it might have done. The brightest it's got to is around about magnitude 1. So this suggests that by the time it's closest to Earth on May the 27th, it'll probably be about magnitude 4. Now, magnitude 4 is a quite reasonable magnitude. It's would be relatively easy to see if it wasn't for the fact that on the 27th, it's going to be deep in the twilight. The earliest we here in Australia are likely to be able to see the comet is around about the 30th. It probably may have faded to magnitude 5 or 6 by then, and so you'll probably see it in binoculars, but it should be a very nice little binocular comet. You may have been seeing some images of the comet before it passed in front of the sun from the northern hemisphere, showing a very nice tail, but all those images were taken with magnification and long exposure, and so we won't see anything like that.
Yep.
Although if we have the chance and the skies favour us, it should be very nice in binoculars, and long exposure photographs should show up the comet very nicely. So if you're looking for the comet, I'll put out some charts later on this week. You'll be able to, at nautical twilight, you'll be able to see Orion very easily. If you go to the star at Rigel, the obvious blue-white star at the base of Orion, which is just above the saucepan or the belt of Orion, and you sweep down from Rigel in the general direction of the horizon, and when you get it roughly about level with Venus on the 30th of April, 1st of May, you should be able to see the comet in binoculars at nautical twilight. As the days go on, the comet rises in the twilight, and by the 8th, it's close to the star Rigel itself and within the same binocular field as Rigel. But by then, it may have faded to just at the limit of binocular view. I mean, we could be wrong. It could end up being brighter than this, but it'll still not be a spectacular unaided eyesight, but it will be a very nice little binocular comet.
Nice.
Very nice indeed, I hope. T Corona Borealis still has gone bang. But we do have the Eta Aquariid meteor shower. This is, again, a very reliable meteor shower, one that favours the southern hemisphere. It's produced by the debris from Halley's Comet. and it peaks on May the 6th this year. So we're going to see better rates on either the morning of the 6th or the morning of the 7th. Unfortunately, this year, the gibbous moon is going to be interfering with the Eta Aquariids, but at the time of the peak, as the Eta Aquariids are rising in the sky, the gibbous moon is setting. So if you manage to block out the moon with a building or other object and preserve your night vision, you should see a reasonable number of meteors. So if you've got dark skies, again, dark skies with a bright moon in it, you should see a meteor around about every 6 minutes or so. Those of us in suburban areas may see a few, quite a few fewer. So this year, our guide to the Eta Aquariid is by planet Saturn. So if you locate Saturn, which is going to be very obvious as the brightest object above the eastern horizon, if you look above that, and if you look to the north, you'll also see the bright star Altair. Roughly between Saturn and Altair, you will see, which should be where the Eta Aquariid meteor shower. Again, the best way is to let your eye rove around the entire patch of sky above the northeastern horizon between the bright Saturn and the bright star Altair. The meteors will generally start their burn away from the notional origin of the meteor shower, the radiant. So if you stare fixedly at that point, you'll probably miss a lot of meteors. The meteors are fast, with few fireballs and persistent trains. Again, I remind you to try and make sure you've got something blocking the moon. So the sky will still be bright, but if the moon is not in your field of vision, that will preserve your night vision. And also get yourself nice and comfortable, chair or a lawn chair to keep yourself comfortable. The nights are getting cooler, so it's well worth making sure you've got warm clothing and mosquito repellent just to keep yourself comfortable.
Exactly. I've got some hills in the east and a nice hill in the west. I'm hoping that the moon will be behind that hill, between, say, 4 o'clock and 6 o'clock in the morning.
Indeed. Yeah. So you should be starting to look around about 3 o'clock, and between 3 o'clock to 6 o'clock, you should be having a reasonable chance of seeing decent meteors. Now, the occultation of Antares, speaking of stars, our full blue moon occults the bright star Antares in the twilight. This is unfortunately a telescope-only event because of the bright moon being very low to the eastern horizon. So you'll need a clear level horizon, and the east coast is favoured. So round about 5 o'clock or so is when the occultation will start. So very obviously this is going to be quite difficult. But if you've got a chance to see it, why not have a go?
Excellent. Yes. Do you have a tangent for us, Ian?
Yes, I do. I'm going to circle back around to our Comet 2026 A1 mass, which is a sun-grazing comet. So, of course, we had high hopes for it, and it broke up spectacularly in the field of view of a number of spacecraft, 2026 A1 mass, but it's a sun-grazing comet. So when we say a sun-grazing comet, what do we mean? Well, obviously, it's a sun-grazing comet. It's a comet that passes extremely close to the sun at perihelion, obviously grazing the sun, sometimes within a few thousand kilometres of the sun's surface. Although some small sun-grazers can completely evaporate during such a close approach to the sun, larger sun-grazers can survive. They can survive many perihelion passages. But of course, they're becoming so close to the sun, you've got enormous amounts of solar energy pouring into them. You've got strong tidal forces, and they often break up. So, Comet Lovejoy was a sun-grazer. It is the famous headless comet, where it rounded the sun and then the nucleus disintegrated as it's on its way out. and gave us a brilliant view here in Australia. But there's been quite a few very important sun-grazers. The Great Comet of 1680, which is now designated as C/1680 V1, was observed by Isaac Newton, and it is his prediction of its path that was a major success for his theory of gravity and played an instrumental role in Newton's gravitational equations being accepted.
Wow.
The Great Comet of 1882 was observed from the clipper ship City of Adelaide on its way to Australia. Now, this is a bit personal because the City of Adelaide was rescued from Scotland, is now dry docked and being restored just down the road from me. And my son Andy helped with some of the restoration process.
Oh, nice.
Yeah. So the sun-grazers are all members of the Aquariid sun-grazer family that I've just talked about. And about 83% of the sun-grazers are members of the Aquariid group. Yep. Now, this all originate from one giant comet that broke up into many small comets many, many years ago. In fact, the extremely bright comet seen by Aristotle in 371 BC is a possible comet for this possible candidate for this parent comet. Now, of course, although the Aquariid sun-grazers are the biggest number and also the most famous group, there's other sun-grazers related to different streams. So we have the cracked and Maya groups of sun-grazers, and both the Marsden and Maya groups of sun-grazers appear to be related to the comet 96P Machholz. So these comets have also been linked to the meteor streams such as the daytime Aretids, the Eta Aquariids, and the Quadrantids. So the linked comet orbits suggest that the comets have a small period, unlike the Aquariid groups, but they're typically small and faint. And while they're small and faint, they're quite easy to pick up in our solar observing spacecraft. Now, we now have a large bevy of solar observing spacecraft that we can use to discover Aquariids comets. In fact, if you're a comet chaser, the large automated sky surveys, which are searching for potentially dangerous asteroids, are picking up a lot of comets. So if you're a visual observer trying to find a new comet, it's a lot harder these days. But visual observers, observers who are using the spacecraft images to discover comets, are having a lot easier time of it. In fact, amateurs are scanning the images coming from the SOHO spacecraft, the STEREO spacecraft. Now we've got the COR1 coronagraph and also the SWAN spacecraft, finding a large number of comets this way and also a large number of sun-grazers. So if you are wanting to discover comets and you're a bit depressed about the chance of discovering comets by simple visual observation with telescopes, you can avail yourself of these spacecraft to see if you can find new comets that way. In fact, for many years, I was a SOHO comet chaser until life got in the way. But again, something like half of all comets discovered of sun-grazing comets have been discovered by independent groups such as the Sun-Grazer Project. So, and you don't need a lot of equipment. You basically need the internet, enough download speed to download very large files from these satellites, and the patience to scan through lots of large images looking for a faint moving speck which become brighter and brighter. I mean, they may be small and tiny, but discovering a sun-grazing comet through these spacecraft is a thrill. And there are lots of people out there monitoring these images to see if they can find even a small sun-grazing comet. So if you have a desire to hunt for comets, go online, download images and start looking for comets. And even if you don't be the first to find one, if you are looking at the SOHO, STEREO and COR1 images at the moment, the Comet C/2025 R3, which is not a sun-grazer, has passed through the COR1 imager, looking very nice. It's still passing through SOHO, and it's passing through one of the stereo images at the moment. And there's some very nice images coming out of that. So go on, give it a go and see what you can see.
Fantastic. Comet hunting.
Comet hunting with spacecraft. It's quite fun, but you do have to spend a consistent amount of time going through the images. And if you have small children, that doesn't necessarily work.
Okay, so if you've got fast internet, do they come down as JPEGs or FITS files? What format do they come down in from the space?
They come down as JPEGs rapidly. If you're wanting FITS files, which are more detailed, you have to wait a couple of days for them to be uploaded to the site. If you're also working with FITS files, you do need to have a viewer which can deal with FITS, and you may have to spend a bit of time adjusting the background in order to bring out the background stars and comets.
Yep.
Once you work out how to do that, once you're familiar with it and familiar with your workflow, it can be very, very rewarding.
Excellent. There's so much joy out there for citizen scientists.
There sure is.
Okay, well, take care. Good night, Ian.
Good night, mate. We'll catch you later, and you have a good time.
Thank you. Cheers.
Cheers. Bye.
In our next guest episode, coming out on May 15th, I'll be speaking with Dr. Jacob Parrott, joining us from the ESA Space Research and Technology Centre in the Netherlands. Jacob is a powerhouse in radio science, leading the charge in deciphering the data from our fleet of Mars orbiters. His work gives us a front row seat to the Mother's Day storm and its devastating impact on a world without a magnetic shield. We're diving deep into the solar fireworks that are stripping the Martian atmosphere and what these high-stakes cosmic collisions tell us about the survival of planets like Mars. Make sure you're subscribed to Astrophiz so you're the first to hear it. And remember, Astrophiz is free, ad-free and unsponsored. Keep looking up. Clear skies.
Radio Wave!